A spherical balloon, with radius r centimeters, deflates at a rate of 60 cubic centimeters per second. We are required to calculate the rate of change of the radius with respect to time, when the radius is 3 centimeters. Firstly, the keyword, deflates, means that the volume of the balloon is decreasing. The rate at which the volume decreases is 60 cubic centimeters per second. Rate of change implies we are dealing with derivatives. In other words, since the volume of the balloon is decreasing over time, we know that dV dt equals minus 60. Note that the minus sign indicates a negative change. We are required to determine the rate of change of the radius with respect to time. In other words, we need to calculate dr dt. Now, since the balloon is spherical, and the volume of the balloon decreases over time, we need to know the volume of a sphere, which is 4/3 pi r cubed. To relate the given information to what we are required to determine, we will use the chain rule. In other words, dV dt is written as dV dr times dr dt. We know the value of dV dt, since it was given. And we know the volume of a sphere, from which we can find the derivative, dV dr. Using the power rule of differentiation, dV dr equals 3 times 4/3 times pi times r to the 3 minus 1. dV dr therefore equals 4 pi r squared. Substituting these values into the expression for dV dt, we get dr dt equals minus 15 over pi r squared. Dr dt represents the rate at which the radius of the balloon changes over time. Since we want to know what this rate of change of radius is when the radius is 3 centimeters, we simply substitute r equals 3 into the expression for dr dt. Dr dt is therefore approximately minus 0.53 centimeters per second. In other words, when the radius of the balloon is 3 centimeters, the radius of the balloon is decreasing at a rate of 0.53 centimeters per second. If you like this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.